All right, so here's today's do now. A particle moves along the x-axis. The velocity of the particle at time t is given as 6t minus t squared. What is the total distance traveled by the particle from 0 to 3? Pause the video, give it a try. Then compare your answers with your neighbors, see if you get the same thing. All right, the focus of today's lesson is volume using known cross-sections. We will define volume as follows. Let S be a solid that lies between x equals a and x equals b if the cross-sectional area of S in the plane P sub x through x and perpendicular to the x-axis is a of x, where a is a continuous function, then the volume of S is given as the limit of the sum of those areas delta x, or the integral of the areas from a to b dx. Essentially what this is saying is that we can find the volume by slicing the three-dimensional shape into cross sections and accumulating the areas across the space. Let's take a look. Example 1. Show that the volume of a sphere of radius r is 4/3 pi r cubed. All right, let's start with a picture, right? So we have a sphere in the coordinate plane, and this sphere we have visually in a two-dimensional plane, but I want you to envision it coming out of the screen and then going back into the screen as well. That way we have this three-dimensional. Now, if I were to take this ball, this sphere, and to slice it perpendicular to the x-axis, we get circles all the way across, right? We get circles from negative r to r vertically across the sphere. And if we make them as thin as we want, we can essentially have these areas, right? These flat two-dimensional circles across this negative r to r. Now, according to this definition, we can find the volume of the sphere by taking these cross sections, these circles, and accumulating them across the space. So we're going to say we have this sample cross section, this circle with radius y, and we want to find its area. Now, we know the area of a circle is pi r squared, but in this case, it's pi y squared for this particular cross section. Now, in order to use this integration to find the volume, we need this function a to be in terms of x. So what we're going to notice is in our sphere that x, y, and r are related by this right-angled triangle. So we know, using Pythagorean theorem, that x squared plus y squared is r squared. So we can modify this equation and solve it for y so that we can create an area of the circle that is in terms of x. Now, if x squared plus y squared is r squared, then y squared is r squared minus x squared, or y is the square root of r squared minus x squared. So we know then the radius of this circle, or y, is just the square root of r squared minus x squared. So now we can rewrite this area of a circle as the area of the circle is pi, the square root of r squared minus x squared, squared. Now, this is kind of nice because that square root and this square are going to cancel each other. So we're left with the area of the circle is just pi times radius squared minus x squared. Now, using this area, we know that if we accumulate these cross-section areas across this circle here, this sphere, negative r to r, we should get the volume. So we're going to say then the volume of the sphere is the integral of these cross-section circles from negative r to r with respect to x. So that is the integral from negative r to r of our area function pi r squared minus x squared dx. Now note, pi is a constant, so I'm going to just pull that from the integral. And now we'll go ahead and find the antiderivative. So note, r squared is a constant, so the antiderivative of constant is a constant times x. So it's just r squared x, and the antiderivative for x squared is 1/3 x cubed. So we get pi, and then r squared x minus 1/3 x cubed from negative r to r. Now, evaluating this, we get pi r squared times r minus 1/3 r cubed minus pi r squared times negative r minus 1/3 times negative r cubed, which when simplified becomes pi r cubed minus 1/3 r cubed minus pi negative r cubed plus 1/3 r cubed. Now note here, r cubed minus 1/3 r cubed is 2/3 r cubed. And then here, negative r cubed plus 1/3 r cubed is negative 2/3 r cubed. Now, simplifying again, we see here a negative times a negative makes this positive. So altogether we get 2/3 pi r cubes. And then here, positive 2/3 pi r cubed. So altogether makes 4/3 pi r cubed. Thus, the formula for the volume of a sphere.